Hi, I'm Catherine, and this is Lab 1, Constant Velocity. Here's the table of contents for this lab. So in this lab, we demonstrate Newton's first law, the law of inertia, which states that an object in motion stays in motion unless acted upon by an outside force. Here we have the velocity and position formulas derived from Newton's law, which in this lab we use to predict the position of a moving object through time, while assuming there were no other forces acting on it. Specifically, a glue stick was rolled across a table with initial force to prompt the initial movement. The assumption was made that there were no other forces aside from gravity and normal force, and that the speed of the glue stick thus remained constant. As seen in these demonstrations, speed is expected to remain constant if there are no other forces such as air resistance or friction, while speed may increase if there's other forces acting on the glue stick in the same direction of movement and vice versa. What was actually observed in the experiment was a decrease in the speed and velocity of the glue stick. So in order to analyze the position of the glue stick through time as it rolled across the table, Tracker was used to analyze a video recording of the glue stick and plot the position versus time. As we can see, the glue stick moved to the right in the positive x direction, which is shown by the positive slope of the graph. To compare the experimental results with the computation and model of the glue stick's position through time based on Newton's first law and the assumption that there were no other forces involved, we used GlowScript and the following lines of code to emulate the velocity and position formulas that we saw previously. The average velocity of the glue stick was calculated using a change in position over the change in time for the first two observations, which was given in a table by Tracker. Here we can see the velocity and position formulas on lines 58 and 60, and we can also see that on line 54 the net force was set to 0 to account for our assumption that there were no other forces acting on the glue stick besides normal force and gravity. Lines 68 and 69 create a plot of the model position through time based on these formulas. In plotting both the experimental position and the model positions of the glue stick, we can see that the experimental position levels out and that the velocity of the glue stick decreases as time goes on. This indicates that there were indeed other forces acting on the glue stick, which may have been friction, acting in the opposite direction, causing it to slow down. In future models, it would be intuitive to take into account the coefficient of friction when generating a model position for the glue stick position throughout time. There are also other possible sources of error that may have contributed to the differences we see, such as the initial force applied to the glue stick and the direction that the glue stick rolled. Since Tracker analyzed the video, if the glue stick weren't completely aligned with the video frame, it may have misinterpreted the position. Also, discrepancies in the surface that it was rolling on may have also affected the results, and also the position of the glue stick was manually entered for each frame in Tracker, so user error could have been another potential source of error. Finally, we answer the what ifs. So if the axes had been flipped, the glue stick would have shown a similar trended movement, but it just would have been in the negative x direction instead of the positive x direction, so we would have seen a negative slope rather than a positive slope. In this lab, we assumed the net force was 0, but based on the experimental results, the net force was not actually 0, as the speed and velocity of the glue stick decreased through time. And so, because we know there were other forces in addition to the force of gravity and normal force acting on the glue stick, it would be really difficult to determine exactly how many other forces, their directions, and magnitudes without further information and experimental setup beyond the scope of this lab in particular. That is my first lab on constant velocity. Thank you for watching.